Hello, class. Happy Thursday. Hope everyone is finding the course material easy to navigate and understand. Feel free to both introduce yourself in the discussion board and fill out the survey for how I can help you succeed in this course. Today, we're going to do the first actual content of the course, and that is about economic theories and data and the interplay between them. I'm going to briefly expand on that using this crime example, and then finish up with a quick discussion of how some type of randomization helps maximize the value of learning about economic theory with data. So to start, this class is all about bringing you up to speed on applying microeconomic theory to economic questions. And start kind of basic, but in the next set of slides, I'll show you some of the really interesting models that have been developed to give insights into issues. And we just know that economic theory is just the development of a model that allows us to test hypotheses. So hypotheses are just predictions about cause and effect. Some models, they make sharp predictions and they're wrong. Some models would make ambiguous predictions that are just plain untestable. The skill is finding an appropriate middle ground for making a model that both provides insight into the question that you're asking and has strong enough assumptions to study that, but it also is not ruling out important factors that are related to the question that you're studying. So the skill is finding that middle ground, which is what the model, most of the models that we'll be using do. And then beyond just developing a theory, we need the data to test that theory. So theory is only useful so long as it actually helps us explain the real world. And to do that, as an economist, what we do is we test the theoretical predictions of economic models with data. And this relationship makes data and theory kind of very strongly related in advancing the body of economic knowledge. So applied microeconomics takes what we're doing in this class in microeconomic theory and tests it in the real world with data. And that's kind of the under the umbrella of econometrics, the applied part of economics. So you have to take, I don't know what the number is, but econometrics to really learn how to take what we're developing, the theory in this course, and apply it more widely. And knowing about these methods can help you understand how data can inform the theory. So I'm going to really briefly talk about what kind of a crucial element of testing theories with data in economics. So just a caveat, my research is primarily applied. So in applied micro, we're taking statistics and data science to test economic theory. I just wanted to briefly talk about the assumptions and how you simplify models so they're useful. And this map right here is itself kind of a model because we're abstracting away from some of the details in real life to help us gain insight into a problem. And that problem is, what is elevation like across the world? So you have to think about what abstractions are actually made in this picture of elevation in the world. And so some things you could list off would be the green color is assumed to be equally low. So it's basically telling you that there's no difference between North Dakota up here or Minnesota and Iowa. But there's probably a difference in elevation there. It's just too small to accurately be modeled in this picture itself. The dark brown is assumed to be equally high. This is Mount Everest over here is dark brown, and this is the Rocky Mountains, and they're both brown, but we know that Mount Everest is the highest point in the world. So we're abstracting away from that more minute difference in elevations to learn about global elevation differences. And this map would help us do that. However, if we wanted to study just the Colorado Rocky Mountains out here, this map doesn't really help us that much because we need to more specifically zoom in on exactly the question that we're interested in finding information about, which would be if we just wanted to do the Colorado Rockies, then we could zoom in on this area and rescale the colors so that we could learn something about elevation in the Western United States mountain ranges. So the appropriate assumptions and scale depend on the question that you're asking. And when we're doing economic theory, it's the same thing, just our model is not an elevation model, kind of like this picture would be, but it's a model about economic behavior. So here's another example about a model that is used. This is an election prediction model, which is of pretty big importance in this year. And so statisticians try to predict election results using polling data. And that's what this picture is over here on the right side. It's a number of different models that use polling data. Like this would be the CBS model, and this would be the Fox News model, and this would be some other polling models, asking how close can they get to actually predicting the election results. And you'd say, well, like they can't put everything into their statistical model that could possibly determine election results. But however, that's not necessarily the question you're asking. You're asking all, as George Box would say, all models are wrong. Kind of sucks, but some are useful. And the practical question is, how wrong do they have to be to not be useful? And all of these models here, I would argue, are somewhat useful because they predict that accurately that Obama would beat McCain in the 2008 elections. They're all, you know, wrong. None of them are exactly on what the popular vote would be, but they're all useful because they all predicted the correct winner. And you know, obviously, some of the models were more useful than other models because you have this IEM model, which is like within a point on each side, and then you have some of these like pollster models, which are off by 3 percentage points, which is a lot of votes in a popular US election. So they don't have the best model. And I had to point this out that this IEM is our election markets. You know, what the heck's an election market? It's literally people betting on who's going to win the election. And it did better than any statistical model. So it's actually people placing bets on who would win, got the closest. So it's just like a free market for predicting who won the election. It did better than any of the statistical models. So economic markets win again. But the theory I want to talk about and the related data that economists use to test it are about police and enforcement and criminal behavior. So you can go down a list of all the times that a program has been put in place where it was designed to put more police on the streets as a way to reduce crime. There's a U.S. war on drugs. There's a Mexican crackdown on gangs in, I think, 2006. About like how if we put more police out there and crack down on crime with more police officers, that will have less crime. And the efficacy or the effectiveness of these programs are debatable. So I want to talk about the economics of it real quick. An individual will commit a crime if the benefit is greater than the cost. You've probably seen that in 201. Point out quickly that benefits and costs don't have to be purely economic. I have no way in saying that. I said benefits have to be good for you or how you feel. So more money makes you feel good, but you know, more stuff makes you feel good. But also, you know, let's say you're just like trying to look cool for your group of friends or some girl you're trying to impress. That would be a benefit to you of committing a crime. And there are costs, the jail time and fine are the obvious like kind of economic costs of time and money, but you could feel guilty due to self-guilt or a disappointed parent. And I've been there, so I know what it's like. A corollary is that economics isn't just about money, it's about how people make decisions. So it really covers a broad range of issues. So as somebody considering committing a crime, you have two options. You can commit the crime if the marginal benefits is greater than the marginal costs, and you don't commit the crime if the marginal benefits are less than the marginal costs of crime. And I'm bringing this word marginal because it's very important in economics to think about the additional unit or the marginal unit of crime. So an example would be like you've spent 5 minutes watching this video or whatever. Is the 6th minute, is the marginal minute, the next minute, more worth it than the cost of watching? I hope so. But so the police, they're trying to catch people and arrest people for committing crimes. If there are more police, the likelihood of being caught goes up, so that in expectation increases the likelihood, or increases the marginal cost of crime. So a higher marginal cost because you're more likely to pay fines, go to jail, etc. And this is kind of a technical point, but it's the probability of getting caught. So there's some uncertainty there. So that's why it's the expected marginal cost. But anyway, a higher marginal cost, crime decreases because it's more costly to commit a crime because it's more likely to get caught. And kind of, we're going to need to be mathematically formal and precise in this class. I'm not the most formal, so the marginal cost of crime, if you have lots of police, is greater than the marginal cost of crime if you have not that many police. And this is kind of, we need a more compact notation than this. So marginal cost of a lot of police is greater than the marginal cost of not that many police. And, it's just putting what I said in words into an equation. And so this would be the, whether or not individual I commits a crime is a function of the marginal cost and the marginal benefit of committing the crime. And I know what that function is. Somebody will do crime if marginal benefit minus marginal cost is greater than 0. Another way of saying that is they'll do crime if marginal benefit is greater than the marginal cost. And you can just add marginal cost to both sides to see that relationship. So I'm going to even stack on a little more mathematical formality here because we're going to have to get used to it as we solve problems in this class. The probability of doing a crime, conditional, this vertical line is conditional. You can just think of it as if marginal benefit is the same in both sides, but marginal cost is high here because there's lots of police, and it's not that high here because there's not that many police. The probability that you do crime is lower or is higher if there's not that many police because there's a lower marginal cost, assuming the same marginal benefit. And this is how I will introduce maybe unfamiliar notation with these brackets here. So probability of committing a crime is this, if this vertical bar, like I said, or more formally conditional on a high marginal cost is lower than the probability of committing a crime if there's not that many police or a low marginal cost involved. What does the data say? Like, oftentimes data on crime and police look like this. I simulated this data, but I could find it in actual data sources if I wanted. It would just take a little bit longer. It's weird, right? Because it says that if there are more police officers, there's a higher crime rate, which isn't consistent with the theory that I literally just showed you in the last couple of slides. Why is that? Well, the reason is if you need to put yourself in a police chief's shoes, where do you send more police? You're not sending them to a gated community where there's no crime. You send them to places with high crime, like the projects or like riots, or not even like a riot or a peaceful protest. You need like people to ensure security there. So you're sending police to places where there's already high crime, and that's responsible for this upward slope here. But does it mean that the theory is wrong? Not really. Like, if you don't account for that non-random assignment of police, you can lead to erroneous conclusions that reject what the theory says. But the problem is that you haven't done a good job with the data. So how do we work around this in economics? Because it's a recurring theme where things that economists are interested in studying are not randomly assigned. Like if I'm interested in the effect of where you go to college, like a private or a public school, on your wages, I can't just flip a coin and send you to a private college if it's tails or whatever, right? Like you get to choose that, and I just get that data of where you went and how much you made, I guess. And how can I say anything about the causal effect of which college you go to on what your wages are? So this video, if you click on it, here's a YouTube video that will show you kind of how economists deal with that. And then and then another question would be like, what are the effects of laptops on course performance? Hint, you do worse if you're allowed to access your laptop, which I think would make a lot of students like upset, especially if it was an in-person course. But you should click on this link if you're more interested in that. But anyway, I can't flip a coin and take away your scholarship or something if it lands on heads, like I said. In a biology lab, I could flip a coin, and if it's heads, water the plant. The non-watered plants might die. You can't just do that with people. So what do? We look for natural experiments that happen. And with the right statistical or econometric tools, natural experiments can be used to recover causal effects of an intervention on an outcome. So a corollary of that would be non-causal studies just are less informative for advancing the theories, just like models with ambiguous predictions are difficult to test. For this specific example, I thought I'd give you a few ways that economists have tried to address this non-random assignment of police officers. Election cycles is one way. So politicians want to improve their chances of re-election by looking tough on crime, so they hire more police. It's probably that the only way that an election affects crime is through its effect on police hiring. So that's one way that people have done it. You've done like terrorist threat levels to as a way that police are assigned to different areas. You can click on any of these and go to these articles. And then 3 is more hawkery referees on the number of penalties, which if you think about it, like a referee is like the police officer of a hockey game. So this is one way that like sports can inform economic theory. So I like sports myself, and it can actually be really helpful to advance in economic theory. These shocks, they're like unlikely to change individual preferences. Like if it's like election time, it's unlikely that that's going to like change whether or not you're more or less disappointed by, or your parents are more or less disappointed with you doing something wrong, or your like desire to impress your classmates or a cute girl. And I say cute girl because it's only guys committing crime pretty much. It's a pretty established finding in the criminology literature. And shocks don't suddenly make the store items more valuable. So like a terrorist threat doesn't make like people want to like make a stolen car more or less valuable. And these random shocks, these random natural experiments that happen are how economists attempt to recover causal effects of interventions that you're interested in on outcomes that we're interested in. So I'm going to wrap this up. Hopefully it hasn't gotten too long. Economists develop theories, and they use that data to test the theory in real life. And theories that are unsupported are redone and tweaked and tested again, and that's kind of like the churn of the scientific method. Point 2 is kind of like the effect of a police on crime is an example of an economic theory, and this theory can be tested with data. But as it shows you, like sloppy data analysis can produce unreliable results that aren't really that helpful. So kind of the third point is a way that you can substantially increase the credibility of tests of economic theories is through randomization. Sometimes that's a lab experiment, sometimes it's a natural experiment that you identify in real life. And just for like your own take home, even outside of this course or outside of economics, is you should be highly skeptical of any test of anything that does not explicitly use randomization, any claim from data. Like before college and before I took econometrics, I was like, oh, a study, okay, that's probably right. But there's differing qualities to the level of study, and you should pay really close attention to that. If anyone comes at me today with, this study says, I asked to see the study, and I evaluate it myself based on whether I think it hits the bar of rigor that I think I can put some trust in the claim that it's being made. So that's pretty much all I have to say about economic data. See the next video for more of insight into economic modeling.